Hi and welcome to my Python YouTube channel. It's awesome to have you here. If you like this video, a thumbs up would be great. And make sure to subscribe for future videos. I also have a blog at prosperocoder.com with lots of cool stuff, so feel free to check it out. Now, in the previous part of the matplotlib series, we created a basic graph. It consists of a figure with just one axis on it. In this part, we'll add some elements to the graph so that it's slightly less basic. So I created another notebook here. This is part 3, so I named it matplotlib part 3. This is my naming convention in this series. And now here, let's first, as a reminder, plot the graph again. So this is the same code as in the previous part. Matplotlib inline, which means the graph should be embedded in the notebook, not displayed in a separate window. Then the imports matplotlib, matplotlib pyplot, and numpy with the commonly used aliases. Then we have the numpy linspace method to create 100 evenly spaced numbers between -10 and 10. And here's our function. It's a quadratic function. Why? Here's our figure and axis. We create them both simultaneously using the subplots function. And here we're actually plotting the graph. So what do we get? We get the following graph of a quadratic function. And now we will plot two more functions on the same graph, each in a different color. Additionally, we will add the labels for the two axes. Here by axis, I mean the x and y axis of the coordinate system. And we'll add the legend. In the legend, you will see the colors of the lines and the names of the functions they represent. So let's start with the code. We'll be using these 100 values between -10 and 10. And now let's define our three functions. We will define functions y1, y2, and y3, like so. The first function is a quadratic function. Actually, it's exactly the same one as here. The second function makes use of the numpy sin, which stands for sine, method, and we multiply the result by 10 so that you can see it better. And the third function is just a linear function, 2x plus 1. Okay, so here are our three functions. Here when I'm saying functions, I mean it in a mathematical sense, mathematical functions. Fine, now let's create the figure and an axis. So, like before, we're going to use the subplots function. And now let's plot the three functions. So, function 1, 2, and 3. Here I also pass the red, green, blue colors so that we can see each function in different color, and labels which will be displayed in the legend. Now, another element we can add is the names of the two axes, x and y. We can do it like so. Set x label to this name and set y label to this name. You will see it in a moment. And finally, let's add the legend. To add a legend, we just use the legend method. Fine. And now we're ready to plot these three functions. Control Enter. Here's the plot. As you can see, now the three functions are in different colors. The quadratic function y1 is in red. The sine function y2 is in green. And the linear function y3 is in blue. We can also see the labels in the legend. Here we're adding the legend, here it is, with the colors of the lines and the names of the functions. And here you can see the names of the axes. This is the x-axis, here's the name x, which we set here. And here's the y-axis with the name y, which we set here. Now you can see the labels for the two axes, x and y, the graphs in three different colors, and the legend. So it looks much better than before. Naturally, there's still quite a lot that we can tweak, and we will, but for the time being, in the next part of this series, we'll see how to add more axis instances to the figure and plot each function in a separate axis. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.